column from the top and go over 5,000. You don't have to go the long way. Okay, you don't have to use your calculator and do 1.07 to the fifth. Okay, so there you go. You don't, I'm just telling you, you can do it either way. Okay, question 9. Garnett owns a commercial building and has a lease with a tenant which calls for rental payments to increase annually. To evaluate the lease, she wants to determine the present value of the building's income and then compare that to her costs. The first year rent is Payments are made on the first day of each year. Assuming a 5% interest rate, the present value of the rental income as of the date of the first payment is what? Okay, right there, it's a present value. So I know I have to use the present value formula. And even though it's a rental, and didn't we say that rentals are annuities? But because the dollar amounts change, you cannot use your annuity formula. You have to use just your standard present value formula. So what you do is you take the present value, hang on, where am I? I'm sorry, down below. Sorry, I lost my place here. So you have to calculate the present value of each of the payments and add them together. Again, you could plug them into the formula like Jonathan said and take the present value times that interest rate. But here's what I did. The first year, because it's paid immediately, there's no interest applied. So I don't multiply or divide that first payment by anything. It's just 10,000 plus. So I take 10,000 plus, then I take the 15,000 divided by 1.05 to give me 14,285. My third year, 20,000 divided by 1.05 to the second power, give me 18. My fourth year, take 15,000, I'm sorry, that's to be 25,000 divided by 1.05, gives you that number. Add them all together, it's 64,022.71. So the answer is C, and you see again how I'm off due to rounding. But did you see how that works? You know you have to do the present value. So you use your present value formula, and you want to add each of the installments together. The tricky thing with this question was knowing that because he said here that at the first of the year they paid 10,000, payments made at the first of the year, that first payment accrues no interest. All right? That's where they're trying to trick you on this question. Otherwise, it's a pretty simple present value formula calculation, minus my little typo there for year 4. Okay, so that was C is the answer in slide 43. We talked about it. Okay, 10. The distinguishing feature between an ordinary annuity and annuity due is that an ordinary annuity due is paid or received at the beginning of each period, while an ordinary annuity is at the end. So that's A, slide 33, we discussed it. Much easier than your calculation questions, except for those of us who are math majors, in which case this whole thing was a piece of cake. Okay, next one. On the day she graduated college, Cameron's family presented her with a check for $10,000, which she immediately deposited into an individual retirement account. The account has paid an annual interest rate of 6% every year for the last 4 years. So how much is in her account today? So because I want to know what the account is today, but I put the money back in 5 years ago, this is actually a future value formula. I know it seems misleading, but remember, future value is I'm taking an amount, putting it in over time, what will it ultimately end up being? So that's why it's a future value formula. 10 grand was the initial payment. It had 4 years to earn 6%, so you multiply it by